finding the vertex point of this general form, we go with the formula. The vertex point of x is finding from negative b over 2a. So we substitute the b and the a value into the formula. B is a negative 5, but keep in mind there was a negative sign from the formula. So you will have the negative 5 over 2, and the a is negative 2. So the vertex point on x-axis has negative 5 over 4. Here turn to a positive 5, and but on the bottom part has a negative 4. So I bring the negative sign to the side. Now, finding the vertex point on y, we just substitute the negative 5 over 4 back to the function. So we have negative 5 over 4 substitute into here, and here has another negative 5 over 4. So solving for this one, you have the negative 2 multiplied by 25 over 16. Minus minus, it turns to a positive 25 over 4. And then plus 3. Reduce 2 and 16 here, I get an a. So I have the negative 25 over 8. I'm going to change the middle term into the same denominator of 8. I mean, I multiply by 2, multiply by 2 here. The last term, integer 3, I replace the 1 to the bottom. Now I multiply by 8 to the numerator and the denominator. And then, these 3 fractions, they all have the same denominator. So I have 24 over 8. Now combine these 3 fractions into a single fraction. Here, minus 25 plus 50, I get a positive 25 plus 24, I have the 49 over 8. So this is approximately like 6 point something. So this is vertex point. Now we need to find the x-intercept and the y-intercept. So let me put down here. X-intercept, we let y equals 0. So that means the entire function I set equals 0 equal negative 2x squared minus 5x plus 3. Because the negative sign in front of the leading coefficient term is hard for me to determine the factor form. So I'm going to divide by negative 1 into the both sides of the equation. And then I bring this side, I swap the direction. It turns to the 2x squared plus 5x minus 3 equals 0. Trinomial, we start from the factor. And because the leading coefficient here is not 1, so I'm going to swing this 2 to the back with the last term. Now we'll have the x squared plus 5x minus 6, set that equals 0. Now this form is very easy for me to factor out. So I know it's a x times x. I will get the x squared. Two number multiply, you can get 6. Sum those two, you can get a positive 5. Only 1 and 6. Because 2 and 3 doesn't work. So the middle term is a positive 5. That means the bigger number is plus, small number is a minus. Now this is a factor form. But don't forget, you just swing the 2 to the back, right? Now we need to giving it back. So the way we giving it back, we divide by the swing number only under the number term. And then you reduce. 6 reduced with 2, you get a 3. Half, you cannot reduce. So I swing the 2 back to the front of the x term. Now your final factor form would be 2x minus 1 multiply x plus 3, set that equals 0. Then from here, I can use the zero factor theorem to find the x term. So x equals negative 3 or x equals half. And in fact, you can find your x value from this form, right? X equals negative 3 or x equals half. So these 2 points that represent your x-intercept. So your x-intercept at half comma 0 or -3 comma 0. Now we need to find the y-intercept. Getting the y-intercept with the x equals 0. So y-intercept with the x equals 0. So now we just simply to substitute the 0 back to the function. So we have -2 0 squared minus 5 multiplied by 0 plus 3. Okay. So -2x squared minus 5x plus 3. So your y-intercept is 3 because the first 2 terms will turn to the 0. So this is your y-intercept at 0, 3. Alright, we have the vertex point ready. We have the x-intercept point ready and the y-intercept point already. So we can sketch the graph. As here you can see this is a vertex point at -5/4, 49/8. It's a down parabola. The x-intercept has -3, 0 and half, 0. The y-intercept at 0, 3. So this point is not necessary you need to find it. Okay, we can just combine the vertex point with your x-intercept. And then combine your vertex point and the other x-intercept as well. Then your graph will be ready to, this is a graph that represents your function. Alright. Okay, so now we move on to the next topic. Use a quadratic function to solve the maximum and the minimum problem. So we look at the example, this one. The Montana Dube Ranchers Association has 400 feet of fencing to enclose a rectangular corral. To save money and fencing, the association intends to use the bank of a river as one boundary of the corral. Find the dimension that all enclose the largest area. So now we need to find the largest area. That means the maximum point on y-axis from your quadratic function. Alright, keep in mind the minimum or maximum, they are also associated with your y value. So the figure is a rectangular shape, and this side there's no fencing along this side, right? So we only have 3 sides. So we know the total length of the fencing is 400 feet. So that means when I combine the 2x, right, this is 1x, the other 1x, we have 2x. Combine the 400 minus 2x, we will get the fencing is 400. That work, right? Now we need to find the area. The area of the rectangle would be length multiplied by the width. Now the length, it defines the length side already. So we just simply to substitute the 400 minus 2x. Multiply the width, since the width is the x. So this would be the area, okay? Or we can write down the f of x. That's the same thing. So this f of x represents the area. Now distribute the right hand side. I'm going to keep the -2x squared in the front because this is the highest leading coefficient term. Plus 400x, and then we have to set that equals 0 because we need to find the maximum point. Now I know this is quadratic function, right? Because the power 2 indicate this is a quadratic function, and the -2 tell us it's a down parabola. So when you have the down parabola, the vertex point that represent the maximum value. That will be the maximum, which means the highest point of this point. So as long as I can find the vertex point on X, then I will find the vertex point on Y, and then that will be the answer question asking for. So finding the vertex point on x-axis, we can use the formula. So negative b over 2a. B is 400, so we have negative 400 on the numerator. The denominator, we will have 2 multiplied negative 2, 100. It's a positive 100. Now finding the vertex point on the y value, we substitute this 100 back to the function. So we will have 400 minus 2 multiplied by 100. And then you multiply by 100 one more time. So here, subtract this 2, you get a 200. Multiply by 100, you will get a 20,000 on the y-axis. So this would be the largest area because this is the maximum point on the y-axis. So the 20,000 square feet, right? This is a square feet that represents the largest size of the area.